Hi, till now we discussed DFA and complement of DFA. Now we'll discuss NFA. NFA stands for non-deterministic finite automata. Non-deterministic means you cannot determine what will be the next step. There will be more than one path. In case of deterministic, there is just one path, so you can determine what will be the next step. Okay. If FA has 0 or more transaction for any input symbol from any state, then it's a NFA. If there is 0 or more transaction, maybe there will be 0 transaction or there will be more than one transaction, then it's NFA. But in case of DFA, there is just one transaction for any input symbol. But in case of NFA, there may be 0 or more transaction from any state. NFA can move to more than one state after taking input symbol. So that is more transaction. There are more transactions, so it can move to more than one state. NFA only about acceptancy, but DFA is both for acceptancy and rejection. So if one string is not belong to that language, then that will be not accepted by DFA. But in case of NFA, if some string is not belongs to that language, it can be accepted. But here you can check for the rejection also. In case of DFA, you can check for the rejection. In case of NFA only, it's about acceptance. NFA take care of only valid input string, no need to take invalid input string. So in NFA, if you will check invalid input string, it may accept it. So NFA just take care of the valid input string. You just take some valid input string and check, it will accept. No need to take care of invalid input string. No concept of dead state and complement, as it is incomplete system. In NFA there is no dead state and you cannot find complement of NF as it is an incomplete system. For incomplete system you cannot find complement. NFA has 5 tuple Q, sigma, then delta, Q0, F. Q is set of state, sigma is input alphabet, Q0 is start state, F is final state. These are same as the DFA, but del is little bit different. Del is Q plus sigma 2 power Q. 2 power Q means it is power set of Q, it can be more states. It is not one state, it can be more than one state. So by taking input symbol, it will go to more than one state, or you can say set of states. For one language, there can be more than one NFA. In case of DFA also, for one language, there can be more than one DFA, but minimal DFA is 1. In case of NFA also, there can be more than one NFA. Expressive power of DFA equal to expressive power of NFA, or you can say it is accepting power or recognizing power. Both are same powerful. But DFA is more efficient than NFA as DFA is more useful. And DFA is a complete system. That's why it is more efficient than NFA. Representation of regular language by NFA is easier than DFA. You will know how it is easier. We'll design NFA. So every DFA is NFA and every NFA can be converted to DFA. There are some processes we can use that and we can convert NFA to DFA. In NFA, there can be multiple transaction path for input string. After taking input symbol, NFA go to multiple path, and if one path end with final state, then it accept this string. So there are multiple path. If any of one path end with the final state, then it will accept this string. So just a diagram representation. This is a DFA. So DFA for any string there is just one path, but in case of NFA there will be multiple path. And if one path end with the final state, then it accept the string. Like here you can see this path end with final state, so it accept the input string. In next lecture we will discuss how to design NFA. Thank you.